So in this lesson, we're going to review a little bit about what we've done the last couple of lessons. We're going to review writing the equation of the tangent line at a given point. And then we'll talk about the function and its derivative graph. And we're going to do a little bit further analysis of how those two compare, the function and its derivative graph. So I'll talk more about that when we get to example 3, but right now we're just going to work on this top portion, writing the equation of the tangent line. And this first one wants us to write the equation of the tangent line for this function at x equals 3. So we're going to need this x point, and then we're going to need our y value, and we're going to need our slope. So to get our y value, we just plug 3 into our function. So y is going to equal 1 minus 3 squared, which is 9. So y is going to equal -8. So our point on this equation is going to be 3, -8. All right, now for our slope. So we're going to take the limit as x approaches 3 of our function minus the function at 3 over x minus 3. And so we're going to have the limit as x approaches 3 of our function, which is 1 minus x squared, and then minus our y value at 3, which was -8. So minus -8 is actually going to be plus 8 over x minus 3. And so we have 1 plus 8 is 9. So I have the limit as x approaches 3 of 9 minus x squared over x minus 3. Now, I've told y'all to be kind of careful about switching these values out. I'm going to go ahead and factor it as it is. So we're going to have the limit as x approaches 3 of 3 minus x times 3 plus x over x minus 3. Now at this point, since I couldn't sub directly in at any point the 3, I know that I need to reduce these. But remember that these are still not exactly the same. So what I need to do is factor out a -1. So I'm going to factor a -1 out of this piece. It would leave me with x minus 3. So now I can factor out the x minus 3. So I've got the limit as x approaches 3 of -1 times 3 plus x. All right, and so now I'm going to plug in my 3. So I have -1 times 3 plus 3, or -1 times 6 is -6. And so that would be my slope. And now I can write my equation. I have y minus the y coordinate, so y minus -8 or y plus 8 equals m, our slope, times x minus 3. On our second problem, they gave us the point 1, 2, so we already know our x and our y value. We just need to find our slope. So we're going to work on our derivative. So we're going to have the limit as x approaches 1 of our function minus our function at 1 over x minus 1. So we have the limit as x approaches 1 of 2 over x minus, and then f of 1 is 2 over x minus 1. All right, so we need to do a little bit of algebra work here because I can't direct sub in the 1. So I'm going to go ahead and combine the numerator here. So I'm going to multiply this by x over x. So I would have 2 minus 2x over x minus 1. And then I'm going to keep the numerator and flip the denominator, keep, change, flip. So limit as x approaches 1 of 2 minus 2x over x times 1 over x minus 1. And I can see here that these are not going to be exactly the same, but I could factor this out. and make it close. So I have the limit as x approaches 1 of 2 times, and this would be 1 minus x times 1 over x times x minus 1. And just like, oh, I'm so sorry, you couldn't see any of that. Let me go over that again. We keep the top and then change the multiplication, flip the bottom, 1 over x minus 1. And then we're going to need to reduce these. So I went ahead and factored out the 2. 2 times 1 minus x over x times x minus 1. And then these are going to be similar as long as I take out a negative. It would change this to x minus 1, and then I can reduce it. So I have the limit as x approaches 1 of negative 2 over x. And so now I can sub in the 1, and I just get that equals negative 2 over 1, or negative 2, and that would be my slope. So now I can write my equation. Y minus the y coordinate equals the slope times x minus the x coordinate. Alright, so in this next section, they're wanting us just to make a match up of the function with its derivative, and we have a couple of choices here. So before we look at that, I want to review what we learned in the last lesson about the graph of the function and the graph of its derivative. So this was the function that we had, and we found the slopes at all of these points. We estimated slopes, and then we graphed them, and we said, okay, we know that whatever our function is, the derivative function is going to be 1 degree less. But let's take that just a little bit further. So I'm going to do a number line sketch of my derivative function. So here's what I mean. This has zeros at 0 and at 2. So it crosses the x-axis. And on the left-hand side, I'm doing a sign analysis. It's positive, and then in the middle, it's negative, and then on the right, it's positive. Okay? So I want you to take a look at the actual function. And on this number line at 0 and 2, I want you to look up there at the original function and see if this is not true. To the left of 0, that function was increasing. In the middle, it was decreasing. And then once we got past 2, it was increasing again. Now, why would that be true? So let me show you. Let me show you the actual function up here. When we got to 0, until we got to 0, the function was increasing. Then between 0 and 2, it was decreasing. And then 2 on, it was increasing. Well, here's why that comparison will always be true. When a function is increasing, the slopes are always going to be positive. And when the function is decreasing, the slopes in that section, the tangent line slopes, will always be negative. And when it's increasing again, slopes will be positive again. So this comparison of the sign analysis of the derivative and its function graph are always going to be true. All right, so with what I just talked about from our last lesson, we're going to look at our function graph first this time and see if we can make that comparison go into our derivative. So here in our function graph, I'm going to make a number line of our function graph, and we know that it until we get to -1, it was decreasing. So it's decreasing on the left, and then after -1, it's increasing. So how is that going to look on our derivative function number line? Well, according to what we just were talking about, let me speed that up just a little bit. That means that on our derivative function graph, to the left of -1 should be negative, and to the right should be positive. So this is our sign analysis graph of what the derivative should look like. To the left of -1, it should be negative, and to the right of -1, it should be positive. So therefore, here's -1. This would be the derivative function graph, because to the left of -1, we've got negative values, and to the right, we've got our positive values. So remember, this one is a sign analysis of the derivative. This is just an increasing, decreasing graph of the function, and that's how they compare with one another. So to take it a step further, this other derivative graph is sign analysis at -1, positive on the left and negative to the right, which means that its original function, I shouldn't have drawn that quite so big, at -1 should be increasing and then decreasing. So that one would be an upside down parabola. Okay, so in this next problem, it's giving us the graph of the derivative of f of x. So this is f prime of x graph. And then they're going to ask us some questions. The questions are about the function, not about this picture, but about the function graph. And so it might benefit us a little bit to go ahead and talk about the sign analysis for this graph. So down below, there's a place for our sign analysis graph. So let's go ahead and fill that out. We know that this graph crosses at -8. You can see all this at once. So it crosses at -8, so we're going to put that down here, and it crosses over here again at 12. And so on the left of -8, the signs are negative, it's below, and then in the middle, above, and to the left, below. Oh, sorry, to the right, below. So negative, positive, negative is our sign analysis. And so what that means for our function, so let's go ahead and fill this in, is that we're going to have decreasing, increasing, decreasing sections of our function graph. Also, we know that since this derivative graph is a parabola, that our function was originally a cube function graph. So let's go ahead and answer our questions, but this sign analysis is going to be helpful. So I think I'll leave it up instead of the derivative picture up there. So it says, on what intervals is the function increasing? Well, we can see that right here. It's wherever our derivative was positive. So the function is increasing on the interval from -8 to +12. Where's the function decreasing? Well, that would be on these outside pieces. So from -infinity to -8, and then again from 12 to infinity. All right, next it talks about maximum and minimum. Well, let's think about that whenever we're looking at our graph. If our graph is decreasing until we get to -8, then it's coming down. And then at -8, it reverses and it goes to increasing until we get to 12. And then at 12, it's going to decrease again. So this is -8, this is 12. So no matter where we are on our y-axis, oh, you could not see me drawing that again, I'm so sorry. All right, so at -8, it decreases until I get to -8, then the function increases until I get to 12, and then it decreases again. So wherever I'm going from decrease to increase, I'm going to have a relative minimum. And wherever it changes from increasing to decreasing, I'm going to have a relative maximum relative to that section of the graph. And so my questions here are, where does the graph have a maximum? Well, it's going to have a maximum where x is 12. And then that minimum is going to be at -8. And then what degree does the function have? Of course, that's x to the third. It's a cubic function graph. Now, I do want to put a little warning out. We're going to be talking about these graphs, the function and its derivative graph, for probably the remainder of the year. And so just be really, really careful, because in this question, they started us out with the derivative graph and asked us questions about the function. But over here on example 3, they started us off with the function graph and asked us about its derivative. So I know that this one is a sign analysis, one is increase, decrease. You just have to be sure you keep all of that straight, because it makes a huge difference when you start answering questions. If you had thought that this was the function graph, then your derivative would have been a line, and all of these answers would have been different. So just be very, very careful.